there are two really important variables when it comes to climate, and that is temperature and water. So, this is an analogy that's really going to help us explain a really important concept that we're going to use in this unit called relative humidity. Really need to understand relative humidity, and I got a way to make sure you understand it, because most people don't really understand relative humidity. You know that humidity means how much water is in the air, but it's not a direct amount. That's specific humidity, and that's not as useful a concept as relative humidity. So I'm going to tell you about relative humidity. So in this analogy here, we have temperature and water. So here's my water. Okay, so water, it's the same amount of water we're going to use for this entire little demo. And these represent the air. So why does a beaker represent air? Because a beaker, what is the purpose of a beaker? The purpose of a beaker is to hold liquids. And so beakers hold water just like air can hold water. All right, so that's why the beaker is air. All right, the water is water, the beaker is the air. So why the different beakers? Well, these different size beakers, they differ because they can hold different amounts of water. And that fits perfectly with air because different kinds of air can hold different amounts of water. And so the variable there is temperature. So some air can hold a lot more water than other air. So the part you have to take on faith is that cold air is going to be the little beaker, and as air heats up, it's going to be a bigger beaker. So from that, you might gather that the big conclusion here then is cold air can hold a lot less water than warm air. All right, so that's one thing we have to remember. Cold air can hold a lot less water than warm air. Warm air holds a lot more water than cold air. So let's start a little demo. So I'm going to just put this in here. Actually, let's put it in this one. So how much water is in that beaker? Well, we could say that we could measure that amount of water, but that's not that useful. It's more useful to just say, well, it's about half full. And in percent, that would be 50%. So we could talk about how that cup is 50% full. What's going to happen if we put it into a different beaker? It's the same amount of water. Is it more or less full? It's less full because we got a bigger beaker. So we put it down in here. This is about 50% full. We move it over here. And oh wow, that's 100% full. So you see how it's the same amount of water, but because we're putting it in different size beakers, the percent fullness changes. So let's think about what that means for air. So if the amount of water in the air doesn't change, but the temperature changes, right? The temperature goes up, the relative humidity, the amount, how full the air is, actually decrease, because even though it's the same amount of water here, at that temperature can hold more. So it's like the beaker increased in size. So it's the same amount of water here. If the temperature goes up, the percent humidity, the relative humidity goes down, because at that temperature it can hold more. So what's the significance of this? There's a couple. As the temperature falls and air can hold less and less water, at some point it's going to get to 100%. What happens then if it cools even more? It's just going to come out. It can't hold it at that temperature. So the water has to come out of the air. And in our model, this is liquid water, but in reality, this water is vapor. And so that when the air can't hold any more water vapor, it's going to come out as a liquid water, and that's going to condense. You might think of that as rain, but it's going to make a cloud that forms. So that's the big takeaway on this, is that relative humidity goes up the colder the air is. Let's take it the other way, though, because this is going to explain a few things. In a little bit, the temperature is going to get kind of cold. In the beginning of winter, the temperature is going to get cold. That's when a lot of you are going to get sick. Maybe not this time because we're all COVID sensitive and we're not exposing ourselves, but that's when the temperature changes, people get sick. And this is one of the main reasons. Cold air, even if it's 100% humidity, right? This is 100% humidity right here, but this is really cold air. So even though it's 100%, it's not holding much water, right? And so it's probably not even 100%. So there's some cold air. Let's say it's even 50%. So it's 50% humid. This is some cold air coming from Canada, and it's 50% humidity, relative humidity. That's the cold air outside, but we don't want it to be that cold in our house. So we take that outside air, we bring it into our house, and we heat it up. Watch what happens when we heat up that air. What's happening to the relative humidity as we heat up that air? It went from 50% down to, we want it to be 70 degrees. What is the relative humidity in that air? It looks like it's maybe less than 5%. That's incredibly dry air. That is so dry that the inside of your nasal passages and the back of your throat are going to crack and they're going to bleed a little bit. And that's when those opportunistic bugs will come in there and infect you. And it's because we take that air that was relatively humid, right? 50%, but as it gets hotter and hotter, as we heat it up on our house, we're creating that super dry air. That's really dangerous in places that it gets super cold, like up in Canada, but it even can happen here. It takes a while for our mucous membrane to kind of kick in, so it's when that temperature changes first that's we're most susceptible, and that's why you get sick. So what can you do? You can add moisture to the air, get a humidifier. That's an important thing that you might want to think about. So relative humidity is going to play a major part in the next 3 videos you see, and so I hope that helped explain it.